Welcome back, everyone. Ready for another deep dive?
Always.
Excellent. Today, we're taking a closer look at the world of quantum technology and its potential impact on, well, pretty much everything.
Yeah, it's going to be big.
Huge, I think. Our guide for this deep dive is a fascinating essay by Yorgoa Schneepat, and he really covers it all, from the mind-bending basics of quantum mechanics, which, let's be honest, still feel a bit like science
All
fiction,
right.
to the potential future scenarios, which honestly also feel a bit like science fiction.
Well, science fiction is often just science ahead of its time.
True that. And Schneepat does a fantastic job of not just highlighting the technological advancements, but also really digging into the ethical and economic considerations that we need to be thinking about right now, like today,
Yeah,
not in some far-off future.
absolutely. We can't just wait until the tech is fully developed and then start thinking about the
Right.
implications.
Exactly. Okay, so let's start with the foundation. What are we actually talking about when we say quantum technology? What makes this different from, say, the computer I'm using right now to record this?
The key difference is that quantum technology harnesses the strangeness, the weirdness of the quantum world.
Okay, bring on the weirdness. I'm intrigued.
All right, well, take something called superposition. You see, in classical computing, a bit is either a 0 or a 1, black or white, on or off.
Right, got it. The foundation of all our current tech.
Exactly. But in the quantum world, a qubit, the quantum equivalent of a bit, it can be both 0 and 1 at the same time.
Hold on. Both 0 and 1 at the same time. How does that even...
It's one of those mind-blowing paradoxes of quantum mechanics. It's like a coin landing on both heads and tails simultaneously.
I'm trying to picture that. My brain hurts a little.
That's quantum mechanics for you. But think about the possibilities. Imagine a computer that could explore every possible solution to a problem all at once. That's the kind of power we're talking about with quantum computers.
Okay. Yeah, I can see how that would be a game changer for, well, just about everything.
Yeah.
So, superposition is one weird thing. What else is there?
Well, how about entanglement?
I've heard that term. It sounds spooky.
It kind of is. Entanglement is this idea that two particles can be linked, connected, somehow. But here's the kicker. They can be light years apart. And if you change the state of one particle, the other one changes instantly, no matter the distance.
No delay. No matter how far apart they are. That's just nuts.
Right. It's like they're communicating faster than the speed of light, which, according to Einstein, shouldn't even be possible. He famously called it spooky action at a distance.
I'm getting chills. But, okay, spooky or not,
Mhm.
how does this translate into actual technology? What can we do with this?
Well, that's where things get really interesting. Imagine, for example, quantum cryptography. Using entanglement, you could create encryption keys that are basically impossible to crack. Any attempt to eavesdrop. It would instantly change the state of the particles, alerting both the sender and the receiver that something's up.
So it's like a built-in alarm system for your data. Like, hey, someone's snooping. That's amazing. What other areas are being impacted by this quantum stuff?
Schneepat really dives into three main areas. Quantum computers, which we've already touched on a bit. Then there's quantum cryptography, as we just discussed. And finally, quantum communication, which is a whole other can of worms.
We'll have to dedicate a whole other deep dive to that.
We definitely could. But before we move on, there's something that Schneepat brings up that I found fascinating. It's this idea of two quantum revolutions.
Two. Okay, you've got to explain this one.
So he argues that we've already experienced one quantum revolution without even really realizing it.
Really? When was this?
Well, think about the invention of transistors
Mm.
or lasers. Those are technologies that completely underpin modern electronics and communication. And guess what? They were built upon our understanding of quantum mechanics.
Hold on. So the devices we're using right now, the internet, our smartphones, all of this is a product of the first quantum revolution.
Exactly. But here's the thing. As Schneepat points out, we're now entering a second quantum revolution. And this one is even more mind-blowing.
Okay, I'm barely wrapping my head around the first one. How is this second one different?
Well, the first revolution was about observing and utilizing quantum phenomena. But this time, we're talking about actually controlling and manipulating those phenomena directly. It's a whole new level of mastery.
I see. So we're not just using fire to generate heat anymore. We're figuring out the chemical reactions, the nitty-gritty of how fire actually works.
A perfect analogy. And that's why this second quantum revolution is so significant. It opens up possibilities that were once pure science fiction. Like, for example, the true potential of quantum computing is only just starting to be unlocked.
So it's not just about making things faster, more efficient. It's about entirely new ways of approaching problems we might not have even thought of yet.
Exactly. We're talking about potentially solving problems that would take classical computers millions of years, even for things like simulating complex molecules, which could revolutionize fields like medicine and material science.
Okay, this is where it starts to feel like we're stepping into the realm of, well, yeah, science fiction again. But let's bring it back down to earth for a moment. What kind of real-world impact could this have on, say, the global economy? Yorgo Schneppet really gets into this in his essay, right?
He does, and he doesn't shy away from the tough questions. He looks at both the incredible potential benefits and the very real challenges we need to be prepared for as this technology keeps evolving.
All right, so let's dig into the details. What are some of the specific industries that Schneppet sees being totally transformed by quantum technology? And what are some of the potential pitfalls, the downsides, that we need to be aware of?
Well, a good place to start is finance, because that's where a lot of early interest and investment is focused. Imagine a world where algorithms powered by quantum computers can perform lightning-fast risk assessments or optimize investment portfolios with an accuracy we can only dream of today.
So Wall Street on quantum steroids.
It's a bit more nuanced than that. Sure, there's the potential for faster trading and maybe even larger profits. But Schneppet also makes the point that quantum computing could actually lead to a more stable financial system overall,
Oh, interesting. How so?
because it could help us manage risk much, much more effectively. And better risk management means a more stable system in theory.
That's a good point.
Mhm.
But what about applications beyond Wall Street? What other fields does Schneppet highlight?
Well, one that really stands out is medicine. Imagine using quantum computers to simulate the super complex interactions of molecules in the human body. We could revolutionize drug discovery. We could design treatments that are so much more targeted and effective than anything we have right now.
So instead of that one-size-fits-all approach, we're talking about personalized medicine, tailored to your specific, unique genetic makeup.
Exactly. And that's just scratching the surface. Quantum computers could help us understand, and maybe even cure, diseases like Alzheimer's or cancer, which have baffled scientists for, well, forever.
Okay, that's pretty incredible. But I know there has to be a but coming.
Mm.
What are some of the potential downsides, the challenges that Schneppet discusses?
He brings up a really important one: the potential for a widening technological gap. If access to quantum technology isn't distributed fairly, it could exacerbate existing inequalities both between nations and within societies.
That's a sobering thought. It's like the digital divide, but on a whole other level. What are some of the other ethical and societal implications that Schneppet raises?
One that really jumps out is this tension between privacy and security.
Yeah.
We've already touched on how quantum cryptography could create this virtually unbreakable encryption.
Right, the ultimate security.
Yeah. But then what happens if governments or, whoever wants to get access to that data?
Right, for like national security reasons or something like that?
Yeah, exactly. How do you balance the need for security with the right to privacy in a world where encryption is basically impenetrable?
It's like an unstoppable force meeting an immovable object.
It's a tough one, for sure. Does Schneppet offer any solutions to these ethical dilemmas, or is he just raising the question?
Well, he doesn't really give concrete solutions, I'd say, but he stresses how important it is to have these conversations now, like right now.
Before it's too late, basically.
Exactly, before the technology gets so widespread that we can't put those ethical frameworks and regulations in place. It's kind of like
Yeah.
we're building this incredibly powerful tool.
But we don't have the instruction manual yet.
Yeah, or we haven't really thought about the safety guidelines.
Right. Powerful tools can be used for good or bad, depending on who's using them and how.
Exactly, and that's where this idea of quantum literacy comes in.
Mhm.
Schneppet is a big advocate for investing in that across all levels of society. Quantum literacy. So like making sure everyone understands the basics of quantum technology.
It's more than just the basics. It's about understanding the potential impacts, the good and the bad.
So it's not enough for just the scientists and engineers to understand this stuff.
Exactly. Everyone needs to be informed, because these decisions about how we use this technology, they're going to affect all of us.
It sounds like he's calling for a kind of global quantum consciousness raising.
Yeah. We need to demystify this stuff, make it accessible, and help people understand why it matters to them. Because it will matter to them whether they realize it or not.
It's like, how do you make quantum mechanics like dinner table conversation?
It's a challenge, but he points to the internet as a model a few decades ago. The internet was this niche thing that only a few people really understood.
Right, I remember those days.
And now, It's everywhere. It's totally woven into the fabric of our lives. The same kind of shift needs to happen with quantum technology. We need to make quantum less Star Trek and more everyday life.
Yeah, bring it down to earth. Because this technology will become part of our everyday lives, whether we're ready for it or not.
Right. And it's not just about those futuristic scenarios, it's about solving real world problems right now, today.
Speaking of real-world problems, Schneepat talks about how quantum technology could help us address some of humanity's biggest challenges, right? Like the really big stuff.
He does. And he's got some really interesting ideas.
All right, so what are we talking about here? Give us some examples. What are the big problems that quantum could help solve?
Well, climate change is a big one. One of the biggest obstacles we face with climate change is the sheer complexity of modeling the Earth's climate system.
Right, there are so many variables, it's mind-boggling.
Exactly. But with quantum computers, we could create these super detailed simulations that factor in all those variables. We could look at everything from ocean currents to deforestation, and that could lead to much more accurate predictions, which could then lead to more effective solutions.
So it's like running what-if scenarios on a massive scale.
Exactly. And it's not just about modeling. Either quantum computers could help us develop new materials for carbon capture and storage, or design way more efficient solar panels.
We could unlock breakthroughs in renewable energy that we haven't even thought of yet.
Right. And it's not just climate change. Think about healthcare.
Okay, yeah, we talked about the potential for like personalized medicine and stuff.
Right. Schneepat is super optimistic about this. Imagine doctors being able to diagnose diseases super early using quantum sensors that can detect tiny, tiny changes at the molecular level.
Wow, so before the disease even really takes hold.
Exactly. Or imagine being able to design personalized therapies that are tailored to an individual's unique genetic makeup, minimizing side effects and maximizing effectiveness.
So it's like moving from a one-size-fits-all approach to medicine to a perfectly tailored suit.
A perfect analogy. And drug discovery. We could dramatically accelerate the development of new drugs and therapies, potentially leading to cures for diseases that are currently considered incurable.
That's amazing. But I keep coming back to this issue of access and equity. How do we make sure that these benefits, these incredible breakthroughs, reach everyone, not just those in wealthy nations or with privileged access?
It's a crucial question, and Schneepat acknowledges that we need to make a conscious effort to promote equitable access to this technology.
So it's not enough to just develop the technology and hope for the best?
Nope. We need to be proactive. This means investing in research and development in developing countries, creating partnerships and knowledge-sharing initiatives. It's about making sure that the benefits of this revolution are distributed fairly.
So it's not enough to just develop the technology. We need to actively work to ensure that it's used to uplift all of humanity.
Right. It's not about leaving anyone behind. Schneepat sees this technology as a potential force for good, a real opportunity to make the world a better place.
But it's not going to happen automatically.
Exactly. We need to be intentional about it. We need to be thoughtful and responsible, and we need to work together to steer this technology in the right direction.
It's both exciting and a little bit daunting, isn't it? This power that we're unlocking.
Absolutely. It's a huge responsibility. And that's why Schneepat emphasizes the need for a global conversation, a real dialogue about quantum technology. It's not just for scientists and policymakers.
It's for all of us.
Right. Everyone needs to be engaged. We need to be having these discussions everywhere, from classrooms to boardrooms to, yeah, even dinner tables.
It's fascinating to think about how this will all play out in our daily lives. Like, will we all be walking around with quantum computers in our pockets? Will our refrigerators be entangled with the grocery store? What are some of the more subtle, everyday ways that Schneepat sees this technology shaping our experiences?
Well, probably not quantum computers in our pockets anytime soon. They're still pretty complex.
Yeah, I figured those would be a ways off.
Yeah, I need those specialized environments and all that. But Schneepat points out that we'll feel the impact of quantum tech in lots of indirect ways, even if we don't realize it.
Like how? Give us some examples. How's this going to sneak into our lives?
Well, think about how we interact with the internet. Quantum cryptography could make online communication basically unhackable.
Oh, wow. So no more data breaches and identity theft and all that.
Potentially. Imagine online banking, shopping, even social media, all completely secure from cyber attacks.
That would be a game changer for sure. I'd
Yeah.
feel a lot better about, doing everything online. What else does Schneepat talk about?
He talks about quantum computers personalizing online experiences in ways we can't even imagine yet.
More personalized than it already is? That's kind of scary, honestly.
Well, think of it this way. Product recommendations, so tailored to your needs, it's like the algorithm knows you better than you know yourself.
Yeah, that is a bit creepy.
Or immersive virtual worlds that are so real it blurs the line between physical and digital.
Okay, now that's just getting into sci-fi territory again. But I can see how that would be appealing to some people.
Right. It's not just the technology, it's the whole new world of applications and experiences that it enables.
Totally. So big changes online. But what about offline? How could this impact things like transportation, agriculture, stuff like that?
Schnippat actually thinks quantum sensors could revolutionize those fields too. Imagine self-driving cars so safe and efficient that accidents are a thing of the past.
That would be incredible, especially with how many traffic accidents there are now.
Exactly. Or think about crops genetically engineered to be resistant to disease and drought.
Oh, wow, that would be huge for food security, especially with climate change and the growing population.
Exactly. It's about creating a more sustainable, efficient, and maybe even more equitable world.
That's a really optimistic vision of the future. But as we've discussed, getting there requires more than just inventing new gadgets.
Oh, absolutely. It's about careful planning, ethical considerations, and a real commitment to sharing the benefits of this tech widely and responsibly.
So what we can do with this technology versus what we should do.
Exactly. What steps can we take to make sure this stuff is used for good? Schneppad had some ideas.
I'm all ears.
Well, he really emphasizes three key areas: education, collaboration, and ethical
Okay,
frameworks.
break those down for me.
So first, we got to educate people about quantum technology, not just the technical details, but the potential benefits and
Right,
risks.
so everyone can participate in these conversations and make informed decisions.
Exactly. Second, collaboration. We need people from different fields, different countries working together on this. Quantum tech is a global endeavor.
Makes sense. No one country or company can do this alone.
Exactly. And that includes supporting research and development in developing countries so everyone benefits.
We need a global quantum ecosystem where everyone has a chance to succeed.
Exactly. And finally,
Ethical frameworks, gotta have those.
by the development and use of this tech, right?
Right. We need to address data privacy, algorithmic bias, potential for misuse, all of that. Now, before it's too late.
It's not just about innovating, it's about innovating responsibly. Precisely. Schneppet's essay is a real wake-up call. It reminds us that the future is not set in stone. It's something we're building right now with every choice we make.
Powerful stuff. So, quantum technology. It's a powerful tool with the potential to revolutionize our world, but how it all plays out is really up to us.
Exactly. It's exciting and a little bit scary, but it's an incredible opportunity to create a better future.
Well said. Thank you so much for joining us on this deep dive into the world of quantum technology.
It was my pleasure.
And to our listeners, keep exploring. Read Yorgo Schneppet's essay, dig into the research, and don't be afraid to ask those big questions. Until next time, keep exploring.